All right, good morning, everybody. Can I get a thumbs up that you hear me and see the presentation okay? Awesome. Okay, so we are working on the financial models day 2. So what I've done is I did not get to do the effective rate at the end of yesterday's notes. So I hope you guys don't mind. I have it at the beginning of today's notes. I'm not going to show you where the actual formula comes from. I'm just going to show you how to use it just for saving time purposes. But obviously, if anybody wants to see the formula being developed, I could obviously do that later on off on the side. But just to be able to use it today, I just want to show you the formulas. So I've written all of your formulas at the top, so you have them all in one place to use them. So you have your simple interest, and that's just interest that is added in at the end of the term. This is where your interest does not get to earn interest. So that's not really great for our money, okay? Then there's compounded interest. That is interest that is going to be calculated and added in over the life of your loan, if you will. So now that your interest can earn interest. And that's what we want, right? We want to make the most money when we invest something. All right. It just depends on your compounding periods, the number of times a year they are willing to stop, calculate your interest, and add it in. And that's N. Those are the compounding periods. And I showed you the common ones yesterday. Yearly, weekly, monthly, continuously, okay? Now you have continuously compounded interest, and that's we call it the PERT formula, where E is involved, because now as N gets really, really big, as you're continuously compounding your interest, obviously this 1 plus 1 over N to the power of N, it heads towards the number E, okay? Now the effective rate. So I didn't get to do this, but here are the formulas. Basically what an effective rate is since compounding your interest is obviously better than not compounding your interest, what the effective rate does is it takes a compounded interest rate and it finds a rate that will, on a yearly rate, that will yield you the exact same amount of money as the compounded interest rate, as if your interest was only compounded once per year. So they use the effective rate to kind of compare investment options. It's basically showing you what the return on your money would be on a yearly basis, okay? So let's do one. So you have an effective rate for when N is obviously a tangible number, like weekly or monthly or daily. And then you have an effective rate for when the interest was continuously compounded, all right? And these guys, those aren't the number E's. These are just the effective rate. That's a subscript of E for the effective rate. But that's the number E over there. All right, so here we go. Look at number 1. Find the effective rate for 5% compounded quarterly. So guys, right now on an investment, they're going to give you 5% per year compounded quarterly. So you're going to get a quarter of that 5% at each compounding period, and then interest gets added in, and now interest earns interest. That's great for us. So the effective rate would be, okay, well, what rate would you need to get the exact same amount of money as this if they only compounded your interest once a year? So clearly our rate, in order to equal this, it would have to be higher than 5%. If I'm only going to compound the interest once per year, the rate that's going to get me the same as 5% compounded quarterly, it's going to be a rate higher than 5%. So we're going to find the effective rate. What rate would yield the same amount of money if your interest had only been compounded once that year, not quarterly? All right, so we just used the formula. The effective rate will equal, and this was quarterly, so we use this one, 1 plus R over N to the power of N and minus 1. The reason we minus 1 is you're basically subtracting out the 100% of your money that you added in, just so we can look at the rate by itself. All right, well, guys, in this problem, we have a rate of 5%, which is 0.05, and we are being compounded quarterly, so N is 4, and in an effective rate, it's always doing it on a yearly basis, so time is always 1, which is why we don't have a time in this formula, because it's always 1. We're always trying to find the effective rate as per 1 year. All right, let's plug in our information, let the formula do all the work. So the rate that would yield the same amount of money as this is going to be 1 plus 0.05 divided by 4 to the power of 4, and then minus 1. And guys, if you don't get a rate, if you don't get a rate higher than 5%, you did not type it into your calculator right. All right, so let's see what we got. So parenthesis 1 plus 0.05 divided by 4 to the power of 4, and then minus 1. and I got, I don't know if you can see that, 0.050945336. I'm going to round that to 2 decimal places. So guys, as a percent, move your decimal 2 to the right. That's going to be 5.09%. So that's the yearly return on your money. Your money, you will see 5.09% of your money on a yearly basis, as per compared to if you had compounded quarterly that year. So this is the rate that would get you the same exact amount of money at the end of 1 year from when your money was invested this way. So when you're compounding quarterly, it only took 5% to end up with that amount of money. But when you're only compounding once per year, it takes a rate of 5.09% to end up with the exact same amount of money here. Does that make sense? What we're finding, you're finding this rate that will get you the same amount of money when something was compounded more. Okay? All right. So again, the reason they do this is they use it to compare investment options. If you go to a bank and they give you all these different ways to invest your money, we'll give you this percent compounded this way, or we'll give you this percent compounded this way. If you want to figure out what's going to earn my money the most interest and therefore end up with the most money, you want to compare the effective rates. Compare them on a compounded once per year. What's your money going to yield on a yearly basis? So they use it to compare investment options. So look at example 2. Suppose you want to open a money market account. It's just something you can invest your money in. You visit 3 banks to determine their money market rates. Bank A offers you this. So let's keep track of this. Bank A is going to offer you a rate of 5%, and you're going to be compounded monthly. So N would be 12. Okay? Then we got Bank B. Bank B is willing to offer you a little bit of a higher rate, 5.04%. But they're only willing to compound it quarterly. So they're not going to compound it as much, but they've given you a higher rate. So now in this investment scenario, N is 4. And then you have Bank C. Bank C is going to offer you the lowest rate yet, but they're willing to compound your interest continuously. So they're going to compound your interest the most, but they've given you the lowest rate. So R equals 4.9%. And then N equals infinity, if you will. So that's just going to be your new formula. We'll use PERT for that one, right? Or actually, we'll use the effective rate with E. All right. Okay, so here we go. So all we have to do to figure out what's going to be the best option for our money is get all of these effective rates. Compare all of these options at a yearly basis. All right, so let's find each effective rate, and whatever effective rate is the highest, that's going to yield you the most money on a yearly basis. So guys, can we do that on our own? Everybody find the effective rate for this, and then I'll do the last one with you because you have to use that new formula just in case you're confused. All right, so I'm going to find this one's effective rate. It's obviously going to be more than 5% to yield the same amount of money. And just don't forget to use your rates as a decimal. And you might want to keep a few decimals for comparison purposes. It might take a couple decimal places to figure out what's the better option. And if anybody's having trouble with the calculator, you can let me know. I'm running out of room. Okay, so just to compare, right now my effective rate is 5.11618979%. That's the yearly interest rate. If interest was only compounded once a year, that would yield me the same amount of money as it being compounded monthly. All right, so that's what this one's looking at. That's what your money would yield on a yearly basis, 5.12% about. All right, let's find this one. And I got all right, so in option B, even though they compounded it less, because they gave me that higher interest rate, I have a higher effective rate. I will yield more money using Bank B. So Bank B is already the better option. And then last, with this one, I use this effective rate, e to the r minus 1. All right, well, the effective rate for the last one is, even though they were willing to compound it the most, they gave you that lowest rate. So a lot of times you'll find, not all the time, but a lot of time, it's hard to beat the bank that's willing to give you the biggest interest rate, because that interest rate is very important. So according to the effective rates, this is what your money would earn on a yearly basis if it was only compounded one time. So this is what your money would yield, 5.14% per year. In this investment, you would earn 5.12% of your money on a yearly basis. So the best scenario to go with to earn the most money at the end of this term is Bank B. You want to choose Bank B. Okay, does that make sense? Can everybody give me a thumbs up if that's okay? These effective rates, again, you're just trying to find an equivalent rate that ends up with the same amount of money as something that had been being compounded versus something that is not going to be compounded. Go ahead, is that a hand or a chat? I don't know. I'll figure. Go ahead, I'll figure this out one day, Michael. What's up?
How come for C you wrote E and then 0.049 minus 1 instead of the other equation?
Because when you're, according to the effective rate formulas, because you use a different formula when your interest is compounded continuously, I would use PERT versus this one. See, these two problems, you would use this compound interest formula, and then with this problem, you would use the PERT formula. So since your interest is being compounded continuously, you use a different effective rate formula. Does that make sense?
Right.
Okay.
Because it's continuously compounded.
Exactly. Only because of the word continuously. That's why. Okay. All right. Go ahead.
Whoops, that was a mistake.
Oh, okay. You're toying with me, Michael. Okay, here we go. Let's look at example 3. So here's the deal, just to save time. Example 3 is the exact same type of problem. It's just figuring out which investment is better. So they're giving you the option between 9% interest compounded monthly or 8.8% interest compounded daily. And you would do the same thing. Find the effective rate for both scenarios. I'm going to skip that one, but I'll fill it in on the notes that I give you in the pictures, just to save time to get to the other examples, okay? All right, so here we go. Another thing they're going to ask you to do in this section is, can you determine the present value? So they may tell you, hey, you had this rate for this many years, compounded this many times, but what money did you start with? What was your initial investment at the beginning? So they're basically kind of turning the problem around, and instead of finding A, the end amount, they're asking you to find P, the present amount. What did you start with initially? So basically, guys, if you take your two compound interest formulas, if you want to know what P is going to equal, solve this for P. Just divide both sides by 1 plus R over N to the N times T. And now we've created a formula that will find the present value for us. So this cancels, and the present value will be equal to A, the end amount, divided by 1 plus R over N to the N times T. Now, guys, if you ask me, we don't really need a formula for this. You would just plug in all of the components and then solve for P. But here is a formula already solved for P. And then, guys, we could even take this formula one step farther, even though I never use this. Since A is being divided by this to the power of NT, you could bring the bottom to the numerator by making that the negative NT, the negative power. So it's also equal to A times 1 plus R over N to the negative NT. I never do that. I just use this one. Your choice, just giving you options. And the same thing, I can solve this formula for P as well, just dividing by E to the RT. And now my present amount will equal A divided by E to the RT. And I can do the same thing. I can bring this to the numerator by making it the negative RT. All right. So these are two formulas that you could use to find the present value, or just plug all the information in and solve for the variable that's left. You really don't need a formula for this. All right, here we go. So let's try see if we can do this. So example 4 says, find the present value. So guys, you're literally being asked to find P, okay? If you get $100 after 2 years at 6% compounded monthly. So guys, $100 is A. That's the end amount. You're going to end up with $100 after 2 years, so that's time. Your rate is 6%, and it's going to be compounded monthly. So N is 12. So if we want to find what money did you start with at the beginning of this investment to end up with $100 with all of this stuff happening, we just got to solve for P. So again, you could plug into the original formula and solve for P. This one's already solved for P, so let's use it. So this says P will equal the end amount, A, which is $100, divided by 1 plus R, which is 0.06, divided by N, which is 12, to the power of N, 12, times T, which is 2. So really that is 24 right there. I would probably plug 24 into my calculator just so that I don't make a mistake with anything that I type. And guys, plug this in. Let's do the calculator, do all the heavy lifting. So we're going to plug in 100 divided by, now guys, obviously don't forget the parentheses. That's important. It's going to keep the denominator together. So 1 plus 0.06 divided by 12 to the power of, and again, I like to plug in 24. I don't like to plug in 12 times 2. I'm afraid that my calculator will do something in a different order. Hit enter. And that means you must have started with $88.72. Done. That's what you put into the account originally to end up with $100 after 2 years with a rate of 6% where interest is compounded monthly. So $88.72. Everybody okay with that one? Just finding the present value. Everybody good? Again, as long as you know what each piece of the problem represents, what variable it is, you just plug it into the formula. All right, let's go to the second page. All right, so this one says, and again, you kind of got to know a little bit about investing, and I'm obviously not an expert on that by any means, but a zero coupon, non-interest bearing bond. So basically what that is you go into a bank and you guys agree that if you put $100 into this account, at the end of a 5-year term, we'll give you this amount of money. It's not like you're given a compounding, you're not actually compounding your interest. You are given an agreed upon amount that your money will end at. So to do it, to figure out, well, what would be a fair amount to end at, they use different investment scenarios like, well, what if we had given you a rate compounded this many times? But a zero non-interest bearing bond is basically you put money in an account and then the bank agrees at the end of a term, we're just going to give you the X amount of money. It's just an agreed upon amount that you end up with. But to figure out what the agreed upon of money should be, they do use investment scenarios like this rate and compounded this many times. All right. So they're saying that this can be redeemed in 10 years for $1,000. So it'll be worth $1,000 after 10 years. So that's clearly time, and that's clearly A. The end amount of this bond will be $1,000. How much should you be willing to pay for it now? So basically your present value, if you want a return of 8% compounded monthly. So if I wanted to end up with the same amount of money, had they given me an 8% rate compounded monthly, well, how much should I be willing to buy this bond for right now? What should be the present value of this bond? All right, so let's plug it all in. So P will equal A, which is $1,000 that we're trying to end at, divided by 1 plus 0.08 is my rate monthly, so N is 12 to the power of 12 times, now guys, we're doing this for 10 years, so 12 times 10. Plug this into your calculator and see what should you be willing to purchase this bond for right now to end up with your $1,000 in 10 years. And again, obviously that's 120, so I'm just going to put in 120 as my exponent. And you should be willing to buy it right now for $450.52. Just watch on your homework, guys, if they tell you to round to the nearest dollar or the nearest cent. So that means you'd have to pay $452 right now to end up with $1,000 at the end of 10 years. Okay, this is the exact same problem, except now what if you wanted to, what should you purchase it for if you wanted your $1,000 compared to 7% compounded continuously? So you'd obviously have to use the other formula, all right? So P would equal, A is still $1,000 divided by E to the RT, right? So E to the 0.07 times 10. So obviously 0.07 times 10 is 0.7. So let's do that one and see what you should purchase it for in that scenario. And you should purchase it for $496.59. Okay, how's everybody doing? Are we okay? Everybody's good? Okay. Okay. Well, the last thing they're going to ask you to do in this section is finding out how to double or triple your money, okay? They may ask you to find what rate is needed to double your money. They may ask you how much time is needed to double or triple your money. So pay attention to what variable you are trying to find, R or T. All right, look at the first one. It says, what annual rate of interest? So guys, right then and there, they're asking you what rate. So we obviously know we're going to be finding a rate. Okay. What annual rate of interest compounded annually, so N is 1, is needed in order to double an investment in 5 years? So T is obviously going to be 5. All right, so they want to know how long, what rate is it going to take to double your investment if the interest is compounded once per year for 5 years. All right, well, guys, think about it. You start with P, right? That's your principal, that's your start money, that's your present value. You want to end up with A being double that. You want A to be 2 times that. So you want your end investment to be 2 times P. 2 times the initial, 2 times the present value. All right, so guys, plug everything into your actual compounded interest formula. So this was compounded annually, so we're going to use this formula. And we want our end investment to be 2 times P, equaling our present value, which is P, times 1 plus, we don't know the rate, guys, so we're going to have to leave R in the formula. They're trying to ask us to find what rate will make this happen, divided by 1, so you don't even have to put it, you could just put plus 1, because it's compounded annually, to the power of N is 1 times T is 5. So guys, basically you have this, 2P equals P times 1 plus R to the power of 5. And your job is now to solve this for R. Now, you could be saying, well, wait a minute, I have 2 variables in this problem. You really don't, because you have one variable compared to another variable. So guys, the first thing I'm going to do is divide both sides by P. If I divide both sides by P, because again, I'm trying to get to R anyway, so I'd have to divide by P, the P's end up dividing out. And you end up with 2 equals 1 plus R to the power of 5. Well, guys, think about this. R is stuck inside the parentheses, right? If this had been 1 plus R squared, how would we have gotten rid of that square? We would take the square roots, right? So how are we going to get rid of a 5th power? We're going to take the 5th root of both sides. So take the 5th root of 2, which is the same thing as 2 to the 1/5 if you want to plug that into your calculator, or it's the 5th root of 2. I'm going to leave it as that for now, just so it's an exact answer. And now the only thing you have to do to get R by itself is minus 1. So your exact answer is the 5th root of 2 minus 1, but guys, we're going to need an answer for that. So the 5th root of 2 Oh, I got to go. I know. I'm just going to do 2 to the 1/5. If you want your fifth root, it's in the math section right here. So you see this one with the X on it? That's your other root, but you got to do this. 5, math, go get that button, and now it's the fifth root of 2. Hit enter, -1, and now it's about, I'm going to say 14.87%. I'm rounding to 2 decimal places. Okay? And you have, that is the rate that you would need to make this investment happen. All right, I'm going to try to sneak in one more before the bell cuts me off. I know I'm always doing this to you guys. I'm sorry, I'm always rushing you. All right, so look at example 7. It says, how long will it take for an investment to double again in value if it earns 5% compounded continuously? So guys, this one's different. This one says how long. So now we're definitely finding time. So time will be the missing variable. How long will it take for an investment to double? So again, I want my present value to end up at 2 times the present value. So I'm doubling my investment. All right, the rate is 5%, and guys, it's compounded continuously. So there's that, constant, n is infinity, basically, even though it's really not. Just means you're going to have to use the PERT formula. So A equals P times E to the RT. Because of the continuously compounding interest, we have to use PERT. All right, so we want our end investment to end up as 2 times the present, so 2P equals P times E to the, my rate is 0.05, and I don't know how long I'll be doing this for. Time is what we're trying to find. So guys, we have to solve this for T, which is an exponent. It's fine, but who's gonna undo an exponential? A logarithm. All right, let's divide the P out, because right now, if we're trying to get to T, we need to get the base of the exponential by itself. So we need to get E to that power by itself. So divide both sides by P, and you end up with 2 equals E to the 0.05t. Okay. So I clearly am solving for a variable that is in my exponent. So I'm going to need a log to undo this. So I could log both sides, or I could natural log both sides. But guys, think about it. That's a BC. Natural log both sides. So you're ending up with the natural log of 2 equals the natural log, which is base E, of a base E exponential, guys, they cancel. And you're left with 0.05t. So now the only thing you have left to do to get t by itself is divide by 0.05. So my exact answer is the natural log of 2 divided by 0.05. But let's actually get a number for that. How many years is that really? Make sure you close the parenthesis on the natural log of 2 so you don't end up putting the 0.05 inside of that log. And it's going to be about 13.86 years, which is roughly 14 years to make this happen. If you want to double your money, it's going to take about 14 years with that rate being compounded continuously. How did that feel? Is everybody okay with solving that one using the logarithm? Is everybody all right? Okay. All right, the last example. I'm obviously not going to do it because I know class is over. I know, guys, I know. It says, how long will it take to triple at this rate? So it's the same exact problem up here, except now you want A to end up as 3 times the present value. So you end up just putting 3P in the equation, and then you solve it the exact same way. All right, I'll fill this in on the notes that I take a picture of and send you guys. But if you just want your investment to triple, then you need 3 times P to be your end amount, and it's the same solving process, okay? All right, guys, I apologize. I know I always go over. If you have any questions, always please reach out to me. You do have a homework. I did not make the homework due till Monday night. Again, in case anybody has busy weekends, I did give you that cushion of Monday after school to complete the homework as well. All right, let me just double check the attendance, and I'll let you guys get out of here. I hope you have a wonderful weekend.